Hey there, my name is David Rodriguez and I am what you might call an industrial time series data nerd. I like to use my powers for the benefit of renewable energy, and what I'd like to show you today is the beginnings of my journey through learning a new tool that's used in this kind of space. It's an open source project called Fledge. It is a framework for edge data that is used. Edge by definition is kind of very close to where the actual action is happening in an industrial setting. So this lives right out by the equipment, and it helps get data from a variety of sources into a single place and routed through to wherever it needs to go. So it could be a cloud target, really anything else that helps it get to where it needs to be and in a form that it needs to be. So I've used it a couple times. I've really liked what I've seen so far. So I kind of want to take a deeper dive into this and share what I find as I go, and hopefully it's useful for at least somebody. So what I'm going to start with today is setting up a Raspberry Pi with Fledge. And I kind of want to show you how it's done from scratch, just in case someone else kind of needs to see how this is done from like step zero. We're going to take a Raspberry Pi and we're going to set it up in a way that makes sense to do with a software like Fledge, because it involves reading and writing to the disk a lot. But the disk in this case on a Raspberry Pi is typically a micro SD card. And if you are reading and writing tons of data to an SD card, it's bound to fail. So if you want to have a proper test environment to run an application like Fledge for an extended period of time, it makes sense to have at least the storage part of it set up over a solid state drive. And we can connect a solid state drive to the Raspberry Pi over USB. But what we're going to do too is actually just set up the whole operating system on that solid state drive, and we'll just have it run from there. I'm going to make it really easy to set up. You're not going to need a display or anything like that. We're just going to set it up as a like headless setup is what they like to call it. So no display needed, and I'll make it so that we can connect to, it'll connect to Wi-Fi automatically, and it'll connect with the same IP address every time, which is important if you're, want to reliably know where it is on your network. All right, so this is pretty much everything we're going to need to get the setup that we're going for. So we got a Raspberry Pi in the middle. It's specifically a Raspberry Pi 4, and this is what I tested out this whole arrangement on. So if you have a Raspberry Pi 3 or older, I can't guarantee this whole USB boot thing will work for you. In that case, maybe try and go the SD card route, or look up a different way to go about it. But with our SSD, we have down here on the bottom with a USB 3.0 converter. There is some method to the madness in what I picked out here, and I will include some resources where I can to show kind of what I relied upon to figure out what worked. And lastly, here is an SD card. This isn't a completely necessary thing, and it's really only used for an intermediary step. You won't need it in the long term going forward. But I actually was able to get away without using it, period. But it kind of seems like the official proper way to do it is with an SD card, so I'll be showing you how we go about that. But yeah, this is it, and let's do it. So we are going to first get the images that we need onto our SD card and onto our solid state drive. So to do that, we're going to be using the Raspberry Pi imager that's made by the Raspberry Pi Foundation. You can get it off of this website here, raspberrypi.com/software. I'm going to be doing this all on a Windows laptop, so if you're following the same thing as me, you would just click download here. I happen to already have this thing installed and set up. It's a very straightforward install, so just gonna pull it up right here. And if you happen to already have Raspberry Pi Imager and you haven't updated it in a while, make sure to get it updated, because the images we're about to use, especially the USB boot one, is a relatively new addition. So let's start with that. I'm gonna pop in our SD card here into the laptop, and we're gonna go to Utility Images and go to the bootloader, and we're gonna do USB boot. Essentially, what my understanding is that when you put this image onto the SD card and you put it into your Raspberry Pi and turn it on, it's going to change the firmware on the Raspberry Pi and tell it to check the USB ports for a boot drive to actually boot up from the operating system instead of doing the normal SD card thing. So that's what we're going to get onto our SD card. See, I have it available here, and it's just a matter of hitting right, and it puts it on the SD card. Okay, easy peasy. That is ready for us now, so I'm just going to pop that out and have that on the ready. Now I'm going to pop in our solid state drive. Okay, so if your the SSD doesn't happen to come up right away, this is a problem I had. Hopefully you don't have it, but it might be that the drive is not initialized yet. You can do that by going to disk management, it's going to look something like this. And I no longer have the option because I already did it, but I believe it would just involve finding the proper disk here. Don't mess with your operating system drive to the SSD. And there should be an option for initializing the disk. And the only trick really to it is to select, to partition it as a master boot record. That's really the main thing. But yeah, if it came up right away, no big deal, you're all set. If not, get that going. And yeah, so the image we're gonna do is, we're gonna go with a 32-bit version of Raspberry Pi OS, and we're gonna do the Debian Buster flavor of it. This is one version back from the the most current version of Raspberry Pi OS. At the moment, Fledge doesn't officially support the newer version, Debian Bullseye, but from what I hear, that'll be coming soon. But yeah, we're just going to stick with this for now. So you have your option of doing it with a desktop environment or not. I'm going to go with no desktop environment. Feel free to grab the desktop one if you so choose. And let's write it to our SSD. Oh, and also just hopefully if you didn't do this stuff already, just it was a fair warning with all this stuff that when we're putting images onto these things, you are blowing away anything that you currently have on those drives. So try not to, just make sure it's all clear and ready to go when you do this. Oops. Okay, all right, so we're all done there. Yeah, sorry, just to probably saw what I was about to do here. I'm going to bring up some documentation here, which we're about to use. And when the Raspberry Pi imager finishes putting that OS onto our SSD, it typically kicks off the SSD. It just, just makes it disconnect. So I'm just gonna slide it right out, pop it back in real quick, make sure that comes up. And we need to do a couple things to our OS to make it, one, connect to our desired Wi-Fi network on boot, and two, make it open to SSH queries, which is how I'm going to choose to interact with it. So first, let's get our boot partition up. I have it over here in Windows Explorer. So first, let's just add a file. You can just do text document, I believe, because we're not actually going to save this extension. All you have to do is literally just make a file called SSH, save it, and that will tell the Raspberry Pi when it starts up to enable SSH. So we got that going for us. And next is to make a file called, let's see, text document. I'm going to double check this. but it is WPA underscore supplicant dot conf. Okay. And we are going to put some information in this that'll tell our Raspberry Pi how to connect. So for getting it to connect to Wi-Fi on boot, we basically need a variation of this configuration, and it is WPA underscore supplicant dot conf. So I'm going to paste that in here. And I currently have a just kind of like a temporary router set up to kind of do this whole setup. So I'm just going to put that information in now. And okay. Oh yes, and country code. If you are in the US, I think this has to do with the, I can't say for sure, but I'm going to put in US. The documentation tells you it is, I think it kind of elaborates right here. So yeah, so that does it. We have both our SSD and SD card set up to get the actual install going on the Raspberry Pi. So with the Raspberry Pi off, I'm going to take our micro SD card and stick it into the bottom. And now I'll turn it on. And you'll see that once it starts blinking rather quickly, that means it's done. It should take about 10 seconds. You can wait 30 seconds to be safe, but that'll be enough time for it to change that boot order in the firmware. Yeah, and if you have a display connected to it, what you'll see is the screen will turn green, and that'll tell you it's done its job. So that seems like about enough time. I'm going to turn it off, and I'm going to pull this SD card out. We are done with it. We don't need it anymore. You can put whatever you like on it now. All right. So next is to get this SSD inserted. So I'm going to put this over USB 3.0. In those resources that I'm going to leave, you might see that it's not exactly a sure shot that USB 3.0 will work. So if you're having any problems there, try it on the regular USB 2.0 port. Yeah, all right. So I got it plugged in, and now it's just a matter of turning it on. All right, it's going to go through its startup process. And so what we need to do is figure out what IP address it got assigned when it connected to our Wi-Fi network. So for that, if you don't happen to know what your router IP address is, hopefully you have management access to your router. That's kind of one thing I am assuming you have here. So I'm just going to do ipconfig and find that my router IP address is this default gateway here. Is 192.168.8.1. So I can reach that in the browser. 8.1. All right, and here's my toy router. It's this fun little $20 thing. All right, so let's take a look at our attached devices. Should be, looks like it just popped on, okay. There's our Raspberry Pi, and it looks like it got assigned the IP address of this. Great. Oh, and just a public service announcement while we're here. I was able to authenticate right away. I'm not sure why it actually saved the password, but typically you have to put in a username password to get to the administrative page of your router. Don't keep that default. That's kind of a security risk. So try and assign yourself a nice long password there for the admin page. All right, so we got our Raspberry Pi IP address, and so now we're going to try and reach it over SSH. Now, I personally like using either the PuTTY SSH client or the MOBA Xterm SSH client. But it is possible just to, if you have a certain version of Windows 10 or greater, you can actually do SSH, an SSH client through the command prompt here. So I'll just show that since that's probably the most accessible. If you do have any trouble getting this set up, it worked out of the box for me, but in case you don't, I'll include another resource on how you might get that enabled on your Windows laptop. But I would recommend MobaXterm or PuTTY as an SSH client. So to SSH into our Pi, we're going to do SSH and the default username of the Raspberry Pi, which is Pi, at, and our IP address. Whoop, which one is it? I think I double tapped. Okay, yeah, it's warning us that like we don't know who this is, but we do. Oh yes, and I have to fully say yes. Okay, prompted for the password. The default password for the Pi username is Raspberry, so I'm going to type that in here. Oops, hopefully correctly. Okay, all right, we are in. So, yeah, so one of the first things we should do right off the bat is just make sure all the packages and utilities are up to date. So to do this, we are going to run sudo or sudo, depending on your preference of pronunciation, apt get update. That's going to go and get the all the relevant packages, and we're just going to say like instead of asking us a bunch of questions, just say yes to everything. We're going to tag along another command just so we can do this all at once. Sudo apt get upgrade. So once those new packages get installed or downloaded, we'll actually install them with this command. So let's run that. Okay, great. So last thing we're going to do here is tell the Raspberry Pi that it should ask the router every time that it's connecting to on boot. We want to ask it for the same IP address every time and hopefully get the same IP address. That's just useful if you're setting up multiple devices, say like something else that's trying to pass data into Fledge and you're doing it over Wi-Fi. It's best to have that IP address, a predictable one. So yeah, we're going to pull back up that documentation here. And we're going to the section for static IP address. So we're going to need to navigate to this file right here, dhcpcd.conf, rolls off the tongue. And let's get a variant of this text inserted. So I'm going to change directory to etc. And I'm going to use a text editor called Nano, which can be run in SSH for this flavor of Raspberry Pi OS. Sudo nano, and it's dhcpcd, was that it? Conf. Hey, that was it. Okay, so I'm going to go all the way to the bottom here and put this in. Okay, now one thing to note here, the example they gave us is assuming you're doing this over Ethernet. We're going to be doing this, of course, over Wi-Fi, the wireless interface. So that is WLAN 0. All right, and the IP address that we want, I'm going to go with, this is specific to you. I'm just going to do 111. And we have to tell it like which router IP address. We got that earlier with ipconfig. So in my case, it's .8.1. And lastly here, you want to specify your DNS server. I will tell it to just use the router if possible. And if not, Google's always there to save you. All right, so that looks good to me. So with Nano, if you want to save this now, I do Control-O. So I guess maybe it means output. Enter to confirm, and Control-X to exit out of the text editor. I don't know why that extra thing is hanging out there. But okay, now that it's configured, we just need to reboot the Raspberry Pi and have it come back with that IP we specified. So I'm going to do sudo reboot and give it a minute to come back. All right, let's try it out here. So before, when we were doing SSH, we were going to that first IP address that the router assigned. But in my case now, it should respond at .111. So let's try it out. That looks about right to me. Okay, we are in. And just another PSA here, now might be a good time to change your default password from Raspberry to something that the rest of the world would know. But yeah, with that, we are pretty much ready for Fledge. I will show you that change password real quick, just in case you're not sure. It is PASSWD. It kind of tells you right there. And so we can do our current password, which is Raspberry, and new password, which I'm definitely not telling you. Okay, yeah, and that's it. So now we can finally get to getting Fledge on here. So I got the Fledge documentation pulled up here, which we're going to be following very closely for this installation process. We're going to be going to the installing Fledge section, go figure. And the first step in it is actually something we already did when we were setting up the Raspberry Pi, just getting all the packages up to date. So we got that taken care of. Now, next up, and I'm not going to pretend to understand all of this, but the general idea is that we are setting up our package manager to know where to go in order to get the Fledge packages. So starts by running this command, and we get a thumbs up from that. And the other thing we have to do is get this line added into this file. So we're going to open up this file here, except, oops, didn't mean to, oh no, I'm in Vim. I was going to say how much I don't like Vim, and now I'm stuck in it. I think it's like :Q exclamation. Yeah, okay. Yeah, I really don't like the VI Vim text editor. Nano is much more intuitive. Feel free to use Vim if you are masochistic. So anyway, I'm gonna get this line added here. Gonna put it in at the bottom. Looking good. Now remember, for Nano it's Control-O, Enter to confirm, and Control-X to get back out. And for some reason, the Windows SSH client likes doing this extra line here. I'm not sure what's going on with that, but it doesn't seem to affect us. So now that we got that set up, let's see, we just need to go ahead and grab all the available updates, all those packages. All right, and now, using a variation of this here, we can actually do the install. So we're going to install Fledge, and we're also going to install the Fledge GUI. Trust me, you want this. It makes interacting with Fledge so much nicer. So yeah, we'll get these two packages installed right now. Or not. I forgot one important letter right there. Let's try it again. Okay, and we are all set. Now, when I was doing testing for this video, during this part of the process, I did one time get a prompt telling me something about Kerberos that I did not fully understand. And I looked into it a little bit, and it told me, and then I saw that you could just pretty much just hit enter and just go through that without any consequence. So second time around, it didn't really prompt me, but just in case that happens to you, don't freak out, just hit enter, get past it, and you should be fine. So we have Fledge installed, and you can see there it's starting the service. So let's go back up. There is a particular location where we can run the Fledge command line utility. It is here. So just to kind of show at the command line level that it's running, we can do this status instead of Fledge start, Fledge status. And there we go. We can see Fledge.1.9.2 is running. And I remember we have the static IP set up, so we know where to go. 192.168.8.111. We should be able to access the Fledge GUI. And there it is. All right, so one last thing I want to show you here is when I was setting this up a while back, one of the times that I went about this, I'm not sure what I messed up in the process, but I spent hours pulling my hair out, not realizing that the web server that the Fledge GUI uses was not running. So let me just show you that real quick. It uses Nginx. I'm just pulling up the service and checking the status. All right, hold on. System CTL Nginx. Sorry. I thought I had that right. Dang it. I think it's status Nginx. There we go. Okay, so that'll tell you, that shows you here that it's active and running. Just thought I'd make sure and include that in case someone else somehow ends up in that same problem. I wish that on nobody. So yeah, anyway, we are fully set up with the normal install of Fledge. All right, so I think I'll leave it here. This will make a good place to start from as I kind of make this journey and learn about the rest of Fledge. There is a lot more to it that I hope to dig into, like Fledge is capable of notifications. You can do calculations on incoming and outgoing data, including machine learning if you so choose. You could run your own custom plugins. You could run Fledge as a Docker container. So there's a lot here to really kind of get into, and I hope to share that as I go. So if you followed along in this video and you found something that didn't look quite right, definitely let me know. I'm only human, so, and also help anybody else that comes along after and takes a look at this. If you did find this to be pretty helpful, let me know. It would really make my day. But yeah, that's about it. So thanks for stopping by.